list of steps for us to follow. You know, that's just the main thing you want to do is just go ahead and bring back the exponent. I'm sorry. If you see any coefficient being multiplied to the log, you want to go ahead and bring that back as an exponent now. So this 4 would come back, and this half would come back as an exponent. Because what we're trying to do now is get all 3 of these logs and condense them into one. And throughout the process, you want to keep the same base going, right? Because when we write it as one log, they all have to have the same base. So actually, you do not want to simplify this out. You just leave it the way it is, right? You don't want to get rid of any of the bases. And that's pretty much it. And we're just going to use the log properties from left to right again. Backwards. Alright, so I'm not going to simplify this because I don't want my common base to go away. Okay, I'm going to bring this 4 back as an exponent. So let's just leave that subtraction there and let's bring back the log. Let's bring it back as half as an exponent. Okay, so now when we look at this addition in between these is implying multiplication with the insides. So from here, I could just write it as 1 log with that same base. And I'm going to multiply the 9 with the x to the 4th. Right? And then minus of 3y to the 1/2. Okay? So now what this subtraction is implying in between them is what I'm going to divide the insides, right? So here's inside, here's inside. Okay, so I'm just going to write this as 1 log now with the common base. There's 9x to the 4th. The subtraction implies that we're going to divide by y to the 1/2. So now we've condensed it all into 1 log, as you can see here. It really all depends on the directions. We're done at this point, but some professors would like you to write exponents as a a radical or something. So you could write this y to the 1/2 as the square root of y. So maybe I should just go ahead and write that. Log base 3 of 9x to the 4th divided by the square root of y. You know, if you're right to as to right answers is radical, but both answers is fine. Okay, so we're gonna go ahead and take this thing and compress it, right? So they always have the same base, but you want to just go ahead and look out for that first, but they typically always do. And you want to go ahead and the coefficients getting multiplied to the logs, bring them back as an exponent. That's the main thing you want to do when you're compressing. So we'll bring back the 3rd, we'll bring back the 3, and you don't want to simplify this because you don't want to get rid of your common base. Okay, so this will do the same thing again. Bring back the 1/3 and then minus log base 2y, and we're going to bring the 3 back. Okay, so now we have it looking like this. I'm not going to simplify this. This addition in between these implies that the insides of the logs should get multiplied together. So 32 should get multiplied to whatever is inside of here, which is x plus 5 to the 1/3. Like that. Minus log base 2 of y cubed. Alright? So now what this subtraction is saying is that whatever is inside of this log should get divided by whatever is inside of that log. So then we get log base 2. We just write it as a single log now. There's the division there. 32 times x plus 5 to 1/3, and then we're going to divide by y cubed. This is all inside the log, right? So we just have a base of 2, and this was all on the inside, and our exponent is just 1, or it's just not there. And that's pretty much it. for this one. And for the x plus 5, again, we're compressing, so this isn't a problem. But don't get it mixed up, thinking that you could do anything with the argument of a log. But yeah, that's pretty much it. Okay, so another one where we have to compress it. So the main thing here is just to bring back anything that's being multiplied to the log, any coefficients back as an exponent. That's really the main thing to look out for when you're compressing. So we're going to bring this 5 back, we're going to bring this 2 back, and that's it for now. So then we'll get log base 3x to the 5th plus log base 3x squared minus log base 3 of 8x to the 5th. So this addition here indicates that the insides of these logs with the same base are going to get multiplied. So x to the 5th is going to get multiplied to x squared. When you have the same base, you add exponents, so x to the 7th. Okay, now since I have the same base, what the subtraction is indicating is that I'm going to divide x to the 7th by whatever is inside this log. So then we get log base 3 x to the 7th divided by 8x to the 5th. This is inside the log. If you could simplify the inside or the argument of a log, well, you might as well do it, right? So we have the same base here. What do you do with the same base when it's division? You subtract exponents, starting from the top. So 7 minus 5 is 2. So the final answer we get is that log base 3, we said 7 minus 5 is 2, right? So we get x squared on top and then an 8 on the bottom. So that would be the answer for that one. Alright, so here's another example. Just want to put up these new laws that we might want to keep on the back of our mind, is that when you have something being raised to an exponent and that log has the same base as that thing, your answer is just what's inside the log. And over here, if you have a log with the same base and the same argument, or what's on the inside, you just end up getting the exponent as the answer. But let's just imagine that we didn't know these laws, and let's just try to solve this by just not knowing that. So this is 5 raised to the log of base 5, and then 25, log 25. So if this 5 wasn't here, what this statement is telling us is 5 to what power would give us 25, which is 2. So all of this would become 2, so we get 5 squared, which is 25. Right? This is if we didn't want to use those properties there. We got 25 doing that. Shouldn't have slashed this out. Okay, now if we do want to use those properties, it's looking like the first one. See how the A and the A repeats here? So the 5 and the 5 is repeating again. So our answer is just going to be what the inside of the log is, which is 25. So that's a good property to keep on the back of your mind, because we don't have to do all that work. We can just jump to the conclusion that the answer is 25. Okay, so here's another example. Let's just assume we didn't know those properties. Just go ahead and do it by what we know. So here's an exponent. Let's go ahead and apply it. So then we get log 4. 4 squared is 16. And what this is telling us is 4 to what power is 16, which turns out to be 2. So we get an answer of 2 with just doing algebra and stuff. But if we look over here, we notice that this is one of those equations that I've written that we should keep on the back of our mind. Notice that the base of the log is the same as the inside. That's the situation we're in right now. So we know our answer is just the exponent. So we could just straight see that the answer is 2. So I would highly suggest just keeping these on the back of your mind. It just saves some time, and they're cool. we could apply those laws to it or statements, but let's just go ahead and try to do it without doing that. So from the log properties, we know that we could bring exponents back. So let's bring this 2 back. So we get 2 times log of base 8, x, and it's got an argument of x. So this is saying x to what power is x, which has to be 1. Also, in general, when you have the same base and this same argument, it's just going to be a 1. That's another common thing about logs. So this turns out to be 1. So 2 times 1 is 2. This is doing it without the properties. So without these 2 equations or facts that I've written here. But if we did want to apply these, we just seek out that it's this one, because the base and the argument are the same. So we could jump to the conclusion that the answer is just the exponent. So the answer here would just be 2, and it's very more convenient to refer back to these, whatever you want to call them, than having to do the algebra, right? Okay, so here's the last example that we have for you to try. And try to do it with the log properties that I've listed here, and try to do it without them if you'd like. So I'm going to go ahead and do it without those properties first. Okay, here, when you have the same base as the argument, that just goes to 1. Or you could look at it as this is saying b to what power is b again, which happens to be 1. So this will be 3 to the first power, which is just 3. So that's the answer. But let's go ahead and use these properties here. It's actually not this one, because the base on the log doesn't match up with what the base is. So you have a b here and a 3 here. It's actually this one in disguise, because this is the base, this is the argument, and then there's the exponent part, right? So which is just a 1 right now. So we're actually dealing with this property here, which tells us that if the base and the argument are the same, we get just the exponent. So here, we're just going to get, this is all going to cancel out, and we're just going to be left with that exponent of 1. So we get 3 to the first power, which is 3 again. So that was kind of a, it was like hiding in there. Had to think about it a little bit. So that was it for the log properties, and I hope to see you guys next time.